welcome everyone. This is the tutorial of the traffic of online games. Thank you very much for being here. This is Mirko Susniewicz, the best player in the world, probably. And I am Jose Saldana. I am not a very good player, but okay, I try. The idea is that we have been asked to present a tutorial about the characteristics of the traffic of online games. The main idea is to just something for information of yours. We are not going to present any new thing. It's just information. Okay, so that's it. The goals of the presentation are these ones: the information about current practices in online games industry, the trends and characteristics of the traffic of online games, and also current network issues and quality of experience requirements. We are going to check with real people, with some volunteers who are going to play some games. In fact, we are going to play 2 games, and optionally, if you want, we can play a third one. And okay, this is it. Okay, and this is also a perfect excuse to play for a while. Okay.
Okay, can you hear me well? First of all, we want to start with some basic information regarding gaming industry, players, and so on. So this is the graph, which is really relatively recent from the New Zoo company, which does market research. They have estimated that total gaming industry is worth around $60 billion last year, and with a year-over-year growth of 6%. You can also see the distribution of players across the continents. So you would say, okay, this is the gaming industry and it is big, but what does it mean for the network? Not all games are network games and they do not impact the network. But okay, but currently there's a lot of shift in the industry towards online. So this shift is driven by several things. First of all, the multiplayer games. People want to play with their friends. This is the indication of how big it is. It is the League of Legends, 3 million concurrent players around the world. So they have 3 million concurrent players at any point, oh, not at any point, but peaked on their servers, on one game. Also, this is motivated by social games, you know, Facebook and all of these Flash-based games. They said that they have over 250 million unique players in a month. Also, one major drive to the online is the content distribution. The data shows that in the last few years, there's a huge increase in the digital format distribution. So people are downloading their games over the internet. They're just not anymore buying the boxed product. Systems such as Steam and so on do this. Also, in the end, there's digital rights management. You have a lot of single-player games which are before were not required to be connected to the internet, now do because of the digital rights management, in order to ensure that those are not forged copies and so on. For example, like Diablo 3. Also, this was all for the PC market. Also, the consoles are having a major shift there. This is the data that Xbox One was supported by 30,000 servers. Xbox Live. Xbox One, 500,000. So you can see how much the industry is moving towards that direction. So I like this slide because there's a general myth that only teenagers play games. And this is data for the US. Average game player age is 30 years. So actually the gamers over 36 years are a larger portion of players than those below 18 years. So this is something to think about because these guys have the money. These guys will purchase new games. So also this is the data from the Entertainment Software Association. Adult women represent a greater portion of the overall game population than teenage men. So this is something to think about. Also, it is indicated that 62% of gamers play with others. So there's also one indication of the shift to the multiplayer to the online.
Okay, there are 2 models for games. Some of them were peer-to-peer, but other ones are client-server. And this model is the one who is now more successful because of 3 reasons. First of all, cheating avoidance. You can control everything in the server, and because some players have developed protocols to cheat, because you can modify the time stamp of your packet in order to say I have shot before or something like that. You can easily synchronize the players, and also for billing. If you have the server, you have more control of the people. Okay, the organization of the server. The server can be included into the game, and then one gamer acts as the server. Okay, you can also have a dedicated server application released, and then the players create their own servers. There are still a lot of online game servers of, for example, Counter-Strike. It's a very old game in which the server was released, and you can just take a computer with a fixed IP address, and then you place it, and everyone can play there. And also the most popular one now is the server fully controlled by the developer or the publisher. For example, in World of Warcraft, which had a peak of 12 million subscribers, all the servers are controlled by the developer. Well, in fact, there is a pirate version of the server, which was the protocol was pirate, but okay, it's not official. And here, okay, there is also this. The games require a specific application for each game. There are also browser-based games, but they are not as wonderful as client ones. Or there are also cloud-based games in which you only have a thin client. It only transmits your orders to the server does everything, renders the video, and transmits you a high-quality video, but the problem is that you need a lot of bandwidth for this. In fact, the normal games, what they do is to place everything in your hard disk, and then the bandwidth is very, very small. So, Mirko, can you show us the size of the folder of World of Warcraft in the hard disk of the computer?
So basically, if you remember, if you played World of Warcraft at the start, it was 5 gigabytes of hard disk space. And overall, as the virtual world evolved, the concept of these games, they store every piece of data on your computer. So your client has a possibility to render the scene, to do everything on its own. So only the state updates are transferred over the network in order to reduce the network load. So in the end, the World of Warcraft is now, after what, 8 years, 9? I don't know anymore, 24 gigabytes of space on your hard disk. So that's an advantage of thin clients. They stay the same, they only stream the video data.
Well, and of course, client version highly affects the traffic characteristics. Different clients have different traffic.
So some more things about business model, because these are very strong drivers that affect the architecture of the games. So generally, you're all familiar, pay to play. You pay for the game, you get your game, and that's it. That was evolved later on. In order for the online games, you need to pay subscription. You need to pay for the time you're going to take to play. And also the model was that when there's an expansion, you also pay for that. But recently, there is much incentive to the free-to-play model. Free-to-play is basically we give you the game. You just play for free. You just download it and you can start playing. But later on in the game, there are some possibilities of small microtransactions, like purchases of, I don't know, virtual weapons, or there are some cosmetic purchases. Some part of the game may be locked, so you need to pay for that additional content. But the thing is, this is really huge. The League of Legends, the game we talked about that has 3 million concurrent players, has that. Dota 2, for example, as well, from Valve, also has the free-to-play model. Everything is for free. You can just download the game and play, and you don't have to pay a dime. So this model very much influences that you need a full server controls. You cannot give players this control of the server. They will give everything you market to the other players. So there is no way that the servers will ever get control, the players will get control of the servers in such games. And how popular it is, Dota 2 is alone taking the almost the same number as all other games on Steam. If you look on Steam and the number of concurrent players, what are they playing? Other games have around 600,000 players, while Dota 2 alone has 400. So that's something to think about.
Okay, we have here 3 potential bottlenecks. We have the clients, the server. So first we have the uplink. The gamers have to send their actions to the server. These flows are really, really small. As we will see in some cases, they are 6 kilobits per second. Next, we have the server processing capacity limit. This is another bottleneck. The server has to be able to do that and to transmit finally in the downlink the state to the players. Sometimes this is difficult because if you have 10 players, okay, it's not a problem. You have to send 9 things to each client. If you have 1,000 people in the same server, what can you do that? How can you do that? The question is that they define, for example, an area of interest, and they only transmit you the things that people in your area of interest are doing. So this is a way that some multiplayer games are using now. And this traffic, of course, includes the player commands, inputs, the virtual world state refreshes, some chat information. You can also chat. Some games have also audio. They have voice over IP systems included. You can say, okay, just fire in the hole, or these kind of things, go, or whatever. And although some players use different applications in parallel with the game, they prefer use Skype or whatever. In Second Life, you can also receive 3D data describing the virtual world, and also video. Cloud-based games are using, in fact, video streams.
So just now about the characteristics of the games. In general, game flows are long-lived. This is maybe an extreme example of 120 hours of World of Warcraft, but in general, I have studied a lot of behavioral sets of World of Warcraft, and the sessions over 8 hours are not an uncommon thing. These games in general have high packet rate and small packets. Also, they have rather low bandwidth usage, and both UDP and TCP can be used. You all better than me probably know how TCP is not designed for real-time virtual worlds, but it does work. So what are the identify issues? The players are very sensitive to delays. So under delays, that's not only the network delay. TCP, if you have losses in TCP, that's sometimes much worse than the network delay. Also, if the server is overloaded, people just refer to that as lag. Lag is everything. It's network delay, it's server overload, it's incapability of the client to process or render a virtual scene. Everything is lag to players. Also, this traffic has very low bandwidth usage, but as we said, there are small packets, so there's a high signaling overhead there. And also, there are variable delivery requirements. Some messages need to be delivered, and some do not. So that's also a problem. So this is all for the regular games. The thin client games, like cloud games, are an exception. And we'll see now why are these packets so small. So in short, market penetration. If you remember the Unreal, the tournament, you could play that on a 14.4K modem. I have played World of Warcraft a lot on the 36.6K modem and had a big bill to pay, I remember. So this is one of the things, because the game industry is rather old now already. So they had to exist in these network conditions which were really poor. And games did work. You remember when you played Quake and so on, all of that worked. So will the high broadband penetration, which is happening now, change this? So this answer is yes and no and no. We will see why. First, game traffic evolution. So there is not really that. There is no evolution. We can see the StarCraft 1 versus StarCraft 2. The first game was peer-to-peer. So the traffic transmitted was highly dependent on the number of players, so 1 to 5 kilobits per second. While StarCraft 2 is purely server-client oriented. As I said, there's a huge move in the industry towards server-client. And there's 2 to 3 kilobits per second. So there is no significant change in this direction. But if you look at the revolution, well, then there is some. These are the cloud-based games, and providers such as OnLive or Gaikai basically do everything on the server. The advantage of this is that you can run the best mega game with the ultra graphics and everything on a really bad computer. So you really, or on your TV and so on. You only need a good network connection. We did an analysis of the OnLive game traffic for a paper, which is currently under revision, and we found out that they have 7 RTP flows in multiplex into 1 UDP flow. So, and the requirements are like 5 megabits per second. So this is very, very, very different from the regular games. The downside is they don't have market penetration. Still, it's not enough. The broadband penetration is not enough, and the OnLive was recently like rebought or something like that. They do deliver quality games, and it can be played, it works, but the market penetration is not so high. So the global trends of game traffic, that's Cisco's report, you can see that the game traffic is still a very, very, very small fraction of overall traffic. It is going to grow by 22% in the next, up to 2017, but still it's a very small fraction of the overall traffic in the network. So.
Okay, these are different categories of games. Action, there are for men, for women, for adults, for young people. Some of the most significant ones are racing, role-playing, and shooters. The shooters are the ones with the tightest requirements. We are going to play just now. Wait for a minute. Role-playing is also very popular. We are going to play it. And the racing, well, we will play if we have time in the end. This is the bandwidth they require. For example, real-time, the axis is logarithm. So you can see that Warcraft 3 requires only 6 kilobits per second, while this cloud game requires 6 megabits per second. There is a lot of variability, but the idea is that they tend to use very, very small amounts of bandwidth. Okay, so this is the first game we are going to play. This is Counter-Strike. It's a first-person shooter. They are all very, very similar. Sometimes they have some little variation. The normal thing is you have a man with a gun and you have to kill mostly anyone. Or, well, sometimes you have to disable friend fire because you can kill your friends and that's not good. You are banned if you do that. But now there is another one which is Wall of Tanks. It's the same as a first-person shooter, but you have a tank instead of a person. And it's good because it tolerates a lot of latency. Because when you are trying to turn the turret to point to the other tank, well, it's 100 milliseconds. Doesn't matter. Don't matter because you have to wait. And between a shot and the next shot, you have to wait like 3 seconds. So okay, 100 milliseconds is not important. So it's very good for us.
Anyhow, can we now have the volunteers? We have been searching for volunteers over the mailing list. We have one person that has, we had 2 persons that applied for Counter-Strike, but only one is here. So maybe is another guy here?
I can play also.
Yeah, if anyone that he hasn't applied, maybe we would really like for 2 guys that are not we, that are not us, to play. Here's another. Okay, please guys, come here. The scenario of this is going to be very, very, very simple. You can play here. The scenario is going to be relatively simple because we want to showcase some issues that can arise due to network conditions. What?
Do you have to have the game started?
Yeah, everything is started, everything is set up, so you can just play here. Alt tab in the network.
The mouse is.
Yeah, the mouse is here. So we're going to stream. I mean, we're going to present from this little laptop of mine. The thing is, we want to showcase the network impairments and how the games are or are not susceptible to those. We'll play just a few rounds. The Counter-Strike is a very, very, very fast game. So we'll first play a few rounds without any impairment. Then we're going to impair, hopefully, the better player. So there's some balance, and we'll do two sets of impairments and see how he felt, how his performance degraded. You can just escape, and this should be okay. Join. The server that we are connecting to is in Zaragoza, so in Jose's lab. So we have a real. This is the traffic going through the internet. You can go and be a cop.
The sound?
Yeah, sound. I have the sound, but maybe guys will be scared about all of the shooting. We'll see. Maybe it works. But if it doesn't work, it doesn't. It's not that important. So, so first, they're going to play an uninterrupted session. So you guys can start. So your name just?
Jan.
Jan and? Victor. So Jan versus Victor, the first competition at IETF. We'll see how it goes. It's only two teams are both here. So okay, don't show the latency next time. It's pretty okay. Okay, the terrorists win. Oh, it's okay. So 1-0 for the terrorists. It's a very simple map. They should be finding each other real quick. Oh, so maybe we do not. Let's do the up to 3. So let's give our police forces another chance. So it's not the laptop. I'm sure it's not the laptop because when I was buying my laptop, I was like, okay, I need a portable thing. It needs to be very lightweight and so on. It needs because I'm going to use it on conferences. And then I bought a desktop replacement, Asus G55, which weighs 5 kilograms. So that's really not an issue here, I think. Get him. Okay. Is the mouse too sensitive or?
Yeah, from you.
Okay, you can just really easily decrease the sensitivity or increase. Okay, one more chance for you. You can increase sensitivity on plus and minus, so you can adapt to that. One more chance. Get him. Oh, okay. So it's going to be a little unfair when I degrade his performance. So.
That's okay.
Okay. So now what are we going to do? We're just going to add some filters and degrade some performance in some sense. I'm not going to tell what is degraded and how much. So you can tell us how much did you feel it. So another round. Okay, again, it's 0-0 maybe. Can they switch computers? Well, we can do that as well. Oh, slow. Ah, he's dominating you. Okay, again.
He has an advantage. He knows what to do.
Aha, he sees him. Oh, that's why. You can do it. You can kill him. Okay, one more time. It's just to have a real.
Actually, I'm better now.
You're better now, huh? Okay. Was that 3 games?
Yeah.
Okay. So, just one question for you. What do you think? How much degraded your performance was? Did you feel any degradation and so on?
Not really, but it could be that it's slower, so I could better react like before.
Aha. So it might be the user interface issue, but exactly what we did, we added some 300 milliseconds of delay to his connection. So you can see the red is his computer, so it has 135, and he has some 450.
This is the RTT delay.
We added the round trip delay of that much, and for this purpose, maybe he's out of his regular playing environment and so on. But for a short while, it seems that even the most requiring games, such as first-person shooter games, are not that susceptible to delay because of the mechanisms that are inbuilt in the clients. The clients have a way to deal with the latency. They have been here a long while before broadband, so the gaming industry has found a way to deal with the latency. On the other hand, for as we said, cloud-based games, this is not the case. So they are very, very, very susceptible to latency, and even if you have more than 250 milliseconds of latency, the game service of online says you cannot play because your network does not support it. So, okay, we're going to do one more degradation for you. Maybe now you're going to do better with this degradation.
They are not cumulative degradation.
Yeah, we're going to switch. So we'll stop this one and open another one. Okay. And let's go. Okay, now you can go. You'll get it. Okay, so some few more games. So in the previous experiment, we added latency. So we're going to add something maybe other now. We'll see how the performance changes. Get him! Oh, get him! Oh yeah, that's the first one, right? Okay, it's another game. No showing latency. Almost. Okay, 1-1. Let's bet. Whoever comes to 3 first, he's the winner. Just to say, the first-person shooters are almost exclusively always UDP based. So they use UDP most of the time. Oh. Okay. Very nice. You have adapted to the mouse.
Oh, it's just because I played it for some years.
It was long ago.
I didn't play it for years, so just needed some time to get.
Okay, we have to continue with the tutorial.
Yeah. Okay. This game, and we'll have to go. Ah, that was unlucky. So, how much degradation did you sense this time? Did you feel that your performance was degraded, that that the game was not responsive or something like that?
Yeah, I think it's just a bit slow to respond to inputs.
Okay, this is maybe because we have added some loss, and not a little loss. We have added 10% of loss for the packets in for this case. So these games are generally relatively resilient to loss. It varies from game to game, but it has been confirmed, for example, for Quake 2, that 30% loss does almost nothing to the game. So on loss, UDP games are pretty resilient, and latency as well. So if we just one more question, and we'll let you go. If we would add if we would add the disruption 30 times smaller than that was in the first experiment, do you think that you would sense it? So it's for the first experiment. So 30 times smaller disruption. Do you think you would sense that?
I think in games, it's all a matter of getting adjusted to it. From my experience, you can, as the player can handle much of the network disruptions just when playing enough with it to get a sense for it, and then adjust his own inputs to, for example, loss. So you foresee it that you have an average 10% loss, so you play a bit more proactive on the inputs, and on the other hand, when you are used to have a very good connection, you are very sensible to suddenly have a drop on package, so you suddenly can't play anymore because the controls behave very differently to what you are used to.
Okay. Okay. Thanks. That would be all for the first round of games. So we have to a bit hurry. So thank you guys. Thank you very much. An applause for our guys.
Okay, these are the cumulative distribution function of three first-person shooter games. We have the client side. And the client side, for example, in Counter-Strike, you can see that it's 40 milliseconds between packets, always or almost always. And the other, where Halo 2 does something similar, but the other game has a big variability there. Here is the packet size. You can see that it's really small. In the client size, 80 bytes or smaller. But the server packets are bigger because they have to send their information. Well, here we have only played one-to-one, but if you play 30 people in the same server, you have to receive the information of 29 people. Well, at the beginning. In the end, it goes down because people are dying, and then the traffic gets down. And here in the server, also the interpacket time varies.
So basically, what we can see here, that they're very narrow. These CDFs are very narrow. You can see here, it's all one value. So they're not spread out a lot. For the inter-arrival times, you can see that almost everything happens between 40 and 80 milliseconds, and here is only 40. So these are very frequent packets for the first-person shooters. Okay, so now some words about MMORPGs. This is the other type of game that we're going to play, but MMORPGs are much different than shooters. They have large virtual worlds, and in these large virtual worlds, you have a large set of activities you can do. I'm always saying, like, from picking flowers to slaying dragons. That's an area of abilities that you can do in such a world. They also have their own economies, and they have a large number of players. In EVO Online, in one big server, there's over 60,000 people. So that's it. Regarding the traffic characteristics, they are much more variable. Especially for TCP-based games, they are much more loss tolerant. They have looser latency constraints than FPS games, and lower packet rate and lower bandwidth usage in general, which you could have seen in that graph with different types of games. So just one more slide before trying to game. You maybe all know much better this than me, but TCP is not designed for this type of application. The traffic is application limited and not network limited. Application sometimes really doesn't have anything to send because the packet rate is not that high. And some mechanisms of TCP are not efficient for MMORPGs and so on. We're now going to do the similar experiment for World of Warcraft just to showcase the difference. So to showcase the difference between an FPS and MMORPG, between a UDP-based game and a TCP-based game. And in general, World of Warcraft works well. You know, there's now 7.7 million players or something like that, but still it uses TCP and works very well in general. But we'll showcase how it may not work well. So where are volunteers for World of Warcraft? Here's one, and Steve, here's another. Oh, thank you for helping us. So you're going to play Hunter here, and Steve, he gets the Hunter, you get the Warrior. You're going to be overpowered, Steve. So you're in ISOC, so you have some benefits. You're going to get overpowered character. It's going to be pretty simple. We are going to do three duels. Come on. And one is going to be without interruptions, and other two will have some interruptions. We'll see that in these games, I don't know how it's going to work. I don't know who is better, but presumably you will be able to see how it is different from the FPSs. Just to log you in. These are the trial accounts that we used to use for our QA study we did on students. Okay. Those are trial accounts because we didn't have money to buy real accounts and buy subscription for World of Warcraft. So the characters are limited to level 20. What we're going to see is just simple duels. They are going to try to kill each other, and that's pretty much it. Just to see whether you guys are next to each other. Okay. This is a simple set of abilities they have. This is creation for arrow and creation for warrior. You can just right-click him up and go duel. And maybe just go near, a bit near, more near to him. Okay. So that's it. The fight will start in 3 seconds. Run away from the warrior. You need to kite him. Use your 3, Steve, use 3. Charge.
3?
Charge is on 4.
4, okay.
Yeah, but you need to be away from him. Charge. Okay, now 2 and 3. 2 and 3. Use 2 and 3. 3 slows him. Yeah.
Who's this other guy?
It's his pet. Oh no, you have been.
Guy in there.
You have attracted a lot of bad attention, Steve. You're going to die.
Leroy!
Oh my God, this is not supposed to happen. In a duel, you never die. You just surrender. But Steve has managed to attract one really bad guy from the surroundings.
But where are that people?
Yeah, that happens. We're going to kill the bad guy now really fast. Okay, bad guy is dead. Okay. So we're going to. So this was the first duel. So Steve, better next time charge away. So then what's it called? Thunderclap him.
I play a hunter, so I don't know.
We're going to now again add some bad stuff for Steve. Oh, maybe that was the problem because this was not really the. I forgot to turn off the laws. That's why Steve couldn't do anything.
That's
I'm sorry,
exactly
Steve.
what the issue was. That's exactly what the issue was.
Yeah.
It was not user error.
No user error. It was the loss was still there. And if you could, the problem is you would probably not see how bad it was because there was no first time. He will easily kill the hunter. You can just eat your fish, please. There's a fish there to recuperate. Okay. And we'll do another set. I apologize for this. So you have maybe seen now how bad it looks when the commands for Steve are not answering. So now we'll do a regular one. Okay. Again, you can duel. Just come a bit near to him. You need to accept the duel and charge away. Charge away. Charge. Yeah.
The pet is doing something?
Oh man, the warrior is pretty overpowered at this level, and Steve is a protection warrior, so I don't really think that he's going to have any problems with defeating the hunter at this point, because there are no degradations.
Yeah.
So again, you'll just a bit. So this was uninterrupted. So now you have you know how it looks when it's not okay. Stop. Okay. Okay. So this is with delay.
They are eating?
They are just eating to recuperate to get their health back. It's in Spanish. Yeah, that's a bit problem. This is like arcane shot. This is you slow with this, poison with that, and this. It's a problem because Jose's computer is in Spanish, so it's a Spanish World of Warcraft. Okay. Now let's go one more with delay. You're again, but you defeat him and then defeat the bad guys. It's not going to be a problem, I think, why you have no loss. Okay, so now just turn around and hit the bad guy. He's going to die. Yeah. Okay. We're now going to, we should have done only 3, but we're going to do another one with loss, so you can see the difference, what the loss does to a TCP game. I'm sorry, Steve, because of the first confusion. Okay, you can also eat, oh, bandage, no, sorry. Eat the fish. And one more time. This time, again, I think even if the Steve doesn't aggro some bad guys around, he'll have much more trouble following the hunter who moves around and slows him down. The problem will be because the game state will not be synchronized well. Steve will see one thing, but the actual representation of the virtual world will be different. So because of the delay and because of the loss. But you will also see something. Okay, try to hit him.
Big difference, though.
Just move around a bit. Okay, Steve has won again. Good work, Steve. But did you sense the difference now with the loss?
I sensed it immediately, actually, when I hit the duel. There was probably about a half-second delay on just the flag dropping itself. So there was a significant keystroke to command delay.
Yes, and there is no, as you can see, there is no significant latency, but the loss the game does not detect that its loss has degraded the performance so much. So thank you very much, guys. Again, one. Okay, not to forget to turn off this. So, as we saw, the loss does affect these games pretty much because of the TCP. So, were there any research regarding another game transfer protocol? Where there was, but it was not widely adopted. But what they did recognize in 2 separate studies that there needs to be transport options. There needs to be multi-streaming, optional ordering, and optional reliability, because there are different types of messages that need to be delivered in these games, such as a tag message, using some mobility, moving message, and chat message. So that's why I was really interested in the previous tutorial, which could enable something like that. So that would, I think that games could benefit from a thing like that pretty easily. So now we here see how the traffic actually looks. And if you remember FPSs, here, this is a server, this is a client traffic. Inter-arrival time, packet size. If you see the packet size, they go all the way. So from 0 to 1,500. So the packets are much more wider spread on the CDF. This can also cause problems because the games are systems that are constantly evolving and changing. And after one patch of World of Warcraft, there was a ISP in UK that their consumers couldn't play. And it was because the ISP's classification system classified the traffic of the games as peer-to-peer. So you might imagine how the outburst of crying of people on the forums was, and they resolved that by just setting the MTU on 500, so they have a bunch of smaller packets, so the ISP's classification mechanism classifies it like games. So we can see that it's much wider spread, although the client size is still small. So client to server traffic is still small, and it's wider spread in the time, so there's a lot less packet rate. Okay, so let's next slide. Does it work? Oh. Okay, why is that? Because as I said previously, MMORPGs have action diversity. You have group-based combat, player versus player combat, single-player combat. So different virtual world settings result in different traffic. And because it's much different than the FPSs, the traffic characteristics are much different. Okay, next one. So we're just going to summarize because we're kind of late. Some of the problems are delay sensitivity, and that's not only network latency. It is very low and inefficient bandwidth usage, very high requirements of the cloud-based game. There's fairness problem. If he has trouble and he doesn't, the players are in unfair positions, so that results in them being not satisfied, scalability problems, and adapting to player behavior, because players tend to be very, very interested at the start of the game and then lose interest, and you need to service all of it on the start in order to it to be successful. And there are, of course, protocol-related issues, as we have demonstrated. Anyhow, thanks.
Okay.
Now,
So
Jose
every show has an advertisement. So in this case, this is this afternoon we are having a buff for multiplexing and tunneling and optimizing traffic of real-time flows. It's not only online games. Online games is just a use case, but online games are also a very difficult case. And if you are able to not to harm the user in offline online game, you are able to deal with anyone. Okay, this is well, this afternoon we will explain it better. Okay, so see you there. And now questions, and if we have time, we will also play a race. But first
we don't
questions.
place questions.
Stuart Shersh, Apple. This is not a question, this is an observation. I'm not a fan of QoS, and the result you showed is interesting, that trying to classify the traffic misclassified it, and whenever people talk about QoS, they always imagine that it will make my application work better, but the hidden assumption is that I'm working better at the expense of making someone else work worse, because if there was sufficient bandwidth, QoS does nothing. QoS only comes into play when you're hurting somebody to benefit somebody else, and I think this is a perfect example where the multiplayer games are not sending a lot of traffic. They don't need an unfair share of the bandwidth. Merely giving them fairness would mean that their packets didn't land at the back of a standing queue. If we had flow separation and their packets had their own queue, as long as they're not using excessive bandwidth, which they're not, then they're not building up buffer bloat and they're not hurt. So we don't need prioritization, we just need the most rudimentary fairness.
Yes, and yes and no. There's actually, for example, if you have innate high latency, for example, a lot of Australians that play on American servers, they have innate high latency. And there's actually services in Australia which say, we're tunneling your traffic, we are making it better so you can actually play. So this is yes and no here.
That gets complicated because what TCP does is related, in terms of misnamed fairness, is related to the round trip time. I'm Jim Geddes, and I think this will help drive something home to this particular community. Anecdote from the buffer bloat wars. When we first got it just about 3 years ago, about buffer bloat, we didn't need a good term for it. It turns out that Dave Clark had seen that in his DSLAM/cable DSL modem, there was insane buffering, and he had figured this out. He used this as a subtle form denial of service attack on his son's excessive World of Warcraft playing. So he could just make it not usable whenever he should be studying and wasn't.
Michael Tüxen, first a remark. The you listed requirements the applications want to see as a service from the transport layer, like partial ordering, like partial reliability, and this. This is exactly the stuff what the RTC web guys are providing for data channels and the
Yeah, I have talked to the WebRTC. Did you say?
Yes.
Yeah, I have talked with them, and that's really interesting in terms of online games.
Yes.
Yeah.
Just
the other
we closed the mics after.
And one question: the UDP-based games, which were very unaffected by high packet loss, what kind of congestion control do they use?
UDP games that are unaffected.
Yeah, you said you showed that there is UDP-based games which were unaffected by high packet loss rates.
Yeah, I think what they do is that just they have a high redundancy, and they have some of the, like dead reckoning mechanisms and interpolation on the client side. So if you press fire, it probably sends not one fire bullet, but 10 packets. Fire.
My question was, what kind of congestion control do they use?
I'm not really sure about that. Okay. So probably not. I don't know.
That was what I thought. Hi, Jason Livingood from Comcast. So as a network operator, we spend a lot of time making sure that gaming traffic works okay, and it's a lot of work. I'll echo what Jim said, which is when in a home network load increases, usually gaming traffic suffers. But the one thing, the main thing I wanted to say here, apart from the fact that this was a very interesting presentation, is I never cease to be amazed at how sometimes little network smarts some of the gaming companies have. For example, when a massive game with millions of subscribers is single-homed and has one data center. So I would urge all of you in this room to please try to go get hired by gaming companies. They need a lot more network smarts.
Okay, thank you.
Okay. So we are out of time.
Yeah, okay.
So thank you. That's the end of our meeting. So this tutorial was like a try to see what the people feel about it. And Spencer and I, as ADs, would like to get some feedback from the community. And either you write directly to Spencer and me, or you post your feedback also to the area list, or if you have specific feedback about the presentation, please go back to the office. Thank you very much.
Your name, he wants your name.
My name, Martin Stiemerling. I'm one of his transporters.